Welcome to unacademy. Let us crack GATE ME. This is Umamaheshwara Rao. Save up to 55% off with up to 6 months free extension for GATE ESE civil subscriptions and mechanical subscriptions. Join the Prarambh batch for GATE ESE PSUs 2025 starting from 31st January 2024. Hurry, valid offer till 27th January. Save up to 55% off on your civil, electrical, electronics and mechanical, chemical subscriptions. With up to 6 months free extension. Offer is valid till 27th January. Unacademy is announcing Prarambh batch. Unacademy is announcing Prarambh batch for GATE ESE PSU 2025. Batch commences from January 31st. Unacademy is announcing Vishwas batch for GATE ESE PSU 2026. Batch commences from January 18th. Nothing can stop you chasing for your GATE and ESE civil dream. Unacademy is congratulating GATE 2023 top rankers. Unacademy is congratulating ESE 2023 top rankers. Get an exam-like experience for GATE 2024. All India mock test for GATE 2024 on 28th January 2024. Welcome to the revision course on engineering mathematics. Today I would like to discuss complex variable and numerical methods. Omega is x square minus y square minus ax plus y plus 2 plus I into 2xy minus 5y plus bx is analytic. U plus IV equal to x square minus y square minus ax plus y plus 2 plus I into 2xy minus 5y minus bx. Now U is x square minus y square minus ax plus y plus 2. V is 2xy minus 5y minus bx. If the function is analytic, clearly CR equations are satisfied. Ux equal to Vy, Uy equal to minus Vx. Now Ux 2x minus a, Vy 2x minus 5. By equating LHS and RHS, you will get the value of a is 5. Similarly, Uy is minus 2y plus 1 minus of Vx 2y minus b, that is minus 2y plus b. Therefore, b equal to 1. A equal to 5, b equal to 1 is the correct answer. A is 5 and b is 1. Next problem. If sin z equal to sigma n equal to 0 to infinite, a6 into z minus 5 by 4 whole power n, then what is the value of a6? A6 equal to coefficient of z minus pi by 4 whole power 6. That is nothing but sixth derivative of f at pi by 4 by 6 factorial. Now f of z is sin z, f dash z is cos z, f double dash z is minus sin z, f triple dash z is minus cos z. Fourth derivative of f is sin z. Fifth derivative of f is cos z. Sixth derivative of f is minus sin z. Sixth derivative of f at pi by 4 is minus 1 by root 2. So this is nothing but minus 1 by root 2 by 720. Minus 1 by 720 root 2. Minus 1 by 720 root 2. The residue of f of z equal to sin z by z power 8 at z equal to 0 is sin z by z power 8 at z equal to 0 is sin z by z power 8 at z equal to 0 is that is z minus z cube by 3 factorial plus z power 5 by 5 factorial minus z power 7 by 7 factorial and so on by z power 8. That is 1 by z power 7 minus 1 by 3 factorial into z power 5, 1 by 5 factorial into z cube minus 1 by 7 factorial into z. Now residue of sin z by z power 8 at z equal to 0 is coefficient of 1 by z, that is minus 1 by 7 factorial. That's why correct answer is minus 1 by 7 factorial. Sigma n equal to minus infinite to infinite a n into z plus 1 whole power n be the Lorentz series expansion z plus 1 whole power n. So we have to express in terms of z plus 1 whole power n. What is the value of a minus 2? A minus 2 means coefficient of z plus 1 whole power minus 2. A2 is nothing but coefficient of z plus 1 whole power minus 2. That is nothing but coefficient of 1 by z plus 1 whole square. What is coefficient of 1 by z plus 1 whole square? So we have to express our series in terms of z plus 1. That's why let us take z plus 1 equal to t, z equal to t minus 1. The function f is sine of z, z means t minus 1, by z plus 1, z plus 1 is t. That is nothing but sine of 1 minus 1 by t, sine 1 cos 1 by t minus cos 1 sine 1 by t. Cos 1 by t is 1 minus 1 by t square by 2 factorial plus 1 by t power 4 by 4 factorial. Cos 1 into 1 by t minus 1 by t cube by 3 factorial plus and so on. That is nothing but f is sine 1 minus sine 1 by 2t square plus sine 1 by 24 into t power 4 minus cos 1 by t plus cos 1 by 60 cube. That can be written as sine 1 minus cos 1 by t minus sine 1 by 2t square plus cos 1 by 60 cube plus sine 1 by 24 t power 4 cos 1 by z plus 1 sine 1 by 2 into z plus 1 whole square cos 1 by 6 into z plus 1 whole cube sine 1 by 24 into z plus 1 whole power 4 and so on. Now what is coefficient of 1 by z plus 1 whole square? Here what is coefficient of 1 by z plus 1 whole square? Minus sine 1 by 2. So the answer is minus sine 1 by 2. Next, the residue of simple poles of f of z 7 minus 3z by z square minus z r 7 minus 3z by z square minus z r. That is 7 minus 3z by z into z minus 1 when you put z equal to 0, 7 minus 0 by 0 minus 1 minus 7, put z equal to 1, 7 minus 3, 4 by 1 plus 4. Therefore, residue of f of z at z equal to 0 is minus 7. Residue of f of z at z equal to 1 is 4. So minus 7 comma 4. Minus 7 comma 4. Next, the value of integral z square plus 3 by z into z square minus 4, where C is the unit circle, mod z equal to 1. C is the unit circle, mod z equal to 1. Identify the singular points. Z equal to 0 is one singular point. Zero lies inside. This is 1. This is minus 1. Another two singular points are plus or minus 2. Minus 2 lies outside. 2 lies outside. Now, only one singular point lies inside. We have to calculate residue at 0. Residue of z square plus 3 by z into z square minus 4 at z equal to 0 is limit z tends to 0 z minus 0 into z square plus 3 by z into z square minus 4. Z cancel. When z is tending to 0, numerator is 0 plus 3, denominator is 0 minus 4, minus 3 by 4. By residue theorem, by Cauchy's residue theorem, the value of integral is 2 pi I into minus 3 by 4. That is minus 3 pi I by 2. Minus 3 pi I by 2. Minus 3 pi I by 2. The value of integral z into e power z by z minus 1 whole cube, where C is mod z equal to 2. that is mod z equal to 2. Now the singular points are 1. 1 lies inside. Okay na? 1 lies inside. Therefore we have to calculate residue at 1. Now the residue of z e power z by z minus 1 whole cube at z equal to 1 is limit z tends to 1 by 2 factorial d square by dz square of z minus 1 whole cube into z into e power z by z minus 1 whole cube. Z minus 1 whole cube, z minus 1 whole cube cancel. That is limit z tends to 1 by 2 d by dz of z e power z limit z tends to 1 by 2. Differentiation of z e power z is z into e power z plus e power z limit z tends to 1 by 2. Differentiation of z e power z is z e power z plus e power z plus differentiation of e power z is e power z. When z is tending to 1, e plus e, that is 3e by 2. So finally residue is 3e by 2 by Cauchy's residue theorem. The value of integral is 2 pi I into 3e by 2. That is 3 pi IE. That is 3 pi IE. Second option is correct. Next problem. The singularity of the function f of z equal to z minus 1 by z square that is z by z square is 1 by z square 1 by z minus 1 by z square. You have finite number of terms in the principal part. Therefore z equal to 0 is a pole. Z equal to 0 is a pole. In the Lorentz series expansion of f of z equal to 1 by z into z minus 1 is valid for mod z minus 1 greater than 1, then coefficient of 1 by z minus 1 is coefficient of 1 by z into z minus 1 mod z minus 1 greater than 1 mod t greater than 1, that is 1 less than mod t, 1 by mod t less than 1. You have to convert in terms of t. Let us take z minus 1 equal to t. Therefore z equal to t plus 1. 1 by Z minus 1 is t, Z is t plus 1. We have to write in terms of 1 by t, therefore t common. 1 plus 1 by t, continuation. 1 by t square of 1 plus 1 by t whole inverse. That is 1 by t square of 1 minus 1 by t plus 1 by t square minus 1 by t cube plus and so on. 1 by t square minus 1 by t cube plus 1 by t power 4 minus 1 by t power 5 and so on. T square. So z minus 1 whole square. 1 by z minus 1 whole cube. 1 by z minus 1 whole power 4. 1 by z minus 1 whole power 5. Finally, coefficient of 1 by z minus 1 is 0. Next problem. The residue of f of z at z equal to 0 is. The residue of f of z at z equal to 0 is. The residue of 1 plus e power z by sin z plus z cos z. Observe, the residue of 1 plus e power z by sin z plus z cos z. F of z is 1 plus e power z by sin z plus at z equal to 0. Numerator is non-zero, but denominator equal to 0. I am going to apply that logic to find out residue. 1 plus e power z by sin z plus z cos z at z equal to 0 is limit z tends to 0. 1 plus e power z by differentiation of sin z is cos z. Differentiation of z cos z is cos z into differentiation of z1 minus z sin z. When z is tending to 0, numerator is 1 plus 1 by 1 plus 1 minus 0. 2 by 2 is 1. So residue is 1. First option is correct. Understood? Next problem. sigma n equal to 0 to 15 z power n, where mod z minus I equal to 2, I is the center, radius 2 units. The circle is I is the center with radius 2 units. Center is I, radius 2 units means this is 3I, I to 0, 0 to minus I 2 units. Now, observe, yeah, clearly I lies inside, okay na? Now, integral f of z is nothing but 1 plus z square plus and so on, z power 15 by z minus I whole power 15 dz by Cauchy's integral formula 2 pi I by 14 factorial into 14th derivative of f at I, 14th derivative of f of z at I, that is 2 pi I by 14 factorial. When you differentiate f, this f, when you differentiate f 14 times, what will come? 14 factorial plus 15 factorial z at z equal to I. 14 factorial plus 15 factorial z at z equal to I. That is nothing but 2 pi I by 14 factorial into 14 factorial plus 15 factorial into I. Take 14 factorial common. If you take 14 factorial common, inside 1 plus 15I, bracket close. This 14 factorial and 14 factorial cancel. So the result is 2 pi I into 1 plus 15I. Final answer is 2 pi I into 1 plus 15I. Understood? One root of the equation e power x minus 3x square equal to 0 lies in the interval 3, 4. The least number of iterations of the bisection method so that modulus of the error less than or equal to 10 power minus 3. This is 10 power minus 3. We have one formula. Lower limit of the interval is 3. Upper limit of the interval is 4. Error of approximation is 10 power minus 3. Error of approximation is 10 power minus 3. Now number of iterations unknown. Now modulus of b minus a by 2 power n less than epsilon. Modulus of 4 minus 3 by 2 power n less than 10 power minus 3. 1 by 2 power n less than 1 by 10 cube. That is 2 power n greater than 10 cube. That is 2 power n is greater than 1000. Take log on both sides. N log 2 greater than log 1000. N greater than log 1000 by log 2. N greater than 9.96. Therefore, the value of n is 10. Understood? Therefore, the value of n is 10. Next. Consider the differential equation. Consider the differential equation. dy by dx equal to x plus y with y of 0 equal to 1 using RK fourth order method with step size 0.2. The value of y at 0.2 is the value of y at 0.2 is okay. Now we have to apply RK fourth order method. dy by dx is x plus y with y of 0 equal to 1. Step size is 0.2. Now function of xy is x plus y. Y naught is 1. X naught is 0. H is 0.2. Now first K1 H of function of x naught y naught H of x naught plus y naught 0.2 into 0 plus 1, that is 0.2. K2 is H of function of x naught plus h by 2 comma y naught plus k1 by 2, that is H of x naught plus h by 2 y naught plus k1 by 2, that is h means 0.2, x naught 0, h is 0.2 by 2, y naught is 1, k1 is 0.2 by 2, 0.2 by 2 is 0.1, 0.1, 0.2, 1.2, 1.2 into 0.2, 0.24. Next, step 3, K3, h of function of x naught plus h by 2 comma y naught plus k2 by 2, h of x naught plus h by 2 plus y naught plus k2 by 2, h is 0.2, x naught 0, 0.2 by 2, y naught 1, k2 is 0.24 by 2, yes, 0.24 by 2, that is 0.12, 0.12 plus 0.1, 0.22, 1.22, 1.22 into 0.2, 0.244. Next, step 4, K4, h of function of x naught plus h, y naught plus k3, x naught plus h plus y naught plus k3, 0.2 of 0 plus 0.2, 1 plus 0.244, yeah, 0.444, 1.444, 0.2888. Next, step 5, k1 plus 2k2 plus 2k3 plus k4 by 6, that is 0.2 plus 2 into 0.24 plus 2 into 0.244 plus 0.2888 by 6, that is 0.2428, 6, y1 equal to y naught plus k, x1 equal to x naught plus h, x naught is 0, h is 0.2, 0.2, y naught is 1, k is 0.2428, final answer is 1.2428. Therefore, the value of y at point 2 is 1.2428. First option is correct. 1.2428. Next problem. RK second order method is applied to dy by dx equal to minus y. Y of 0 is y naught with the step size h. Then the value of y of h is. Then the value of y of h is. Dy by dx equal to minus y. Therefore, function of xy is minus y. Y of 0 equal to y naught. Y naught equal to y naught, x naught equal to 0. Step size h is h. We have to apply RK second order method. Step 1, K1, h of function of x naught y naught. Function of xy is minus y. Therefore, function of x naught y naught is minus y naught. H is h. Y naught is y naught. Therefore, minus hy naught. Step 2, K2, h of function of x naught plus h, y naught plus k1, h of minus of y naught plus k1, that is h of minus y naught minus k1 is plus hy naught, that is minus hy naught plus h square y naught. Next, step 3, k is k1 plus k2 by 2. k1 is minus hy naught. k2 is minus hy naught plus h square y naught by 2. Minus hy naught plus h square y naught by 2. That is y naught by 2 of h square minus 2h. Fourth one, y1 equal to y naught plus k. Y naught plus y naught by 2 of h square minus 2h. Finally, y naught of 1 plus h square minus 2h by 2. That is y naught by 2 of h square minus 2h plus 2. The value of y1 is, the value of y after first iteration is y naught by 2 of h square minus 2h plus 2. Therefore, second option is correct. H square minus 2h plus 2. Understood? Next problem. dy by dx equal to x plus y. Y of 0 equal to 0. Using Euler's method with the step size 0.1. The value of y at 0.3 is. We have to apply Euler's method. dy by dx equal to x plus y. Function of xy is x plus y. Y of 0 equal to 0. That is y naught is 0 when x naught is 0. Y naught is 0 when x naught is 0. Step size h is 0.1. Now we have to calculate y of 0.3. So 3 iterations are required. Now first iteration. y1 is y0 plus h of function of x0 y0. Function of x0 y0 is x0 plus y0. y0 is 0, h is 0.1, x0 0, y0 0, finally 0. x1 is x0 plus h, 0 plus 0.1, that is 0.1. Now second iteration is y2 equal to y1 plus h of function of x1 y1, x2 equal to x1 plus h, x1 is 0.1, h is 0.1, that is 0.2. Now y1 plus h of function of x1 y1 is x1 plus y1. y1 is 0, h is 0.1, x1 is 0.1, y1 is 0. Okay na? Now 0.1 into 0.1, 0.01. Next, third iteration. y3 is y2 plus h of function of x2 y2. x3 is x2 plus h, 0.2 plus 0.1, that is 0.3. Now y2 plus h of x2 plus y2. y2 is 0.01 plus h is 0.1, x2 is 0.2, y2 is 0.01, 0.21, 0.021, 0.031. Finally, the value of y at 0.3 is 0.031. Final answer is 0.031. This is the problem on Euler's method. This is modified Euler's method. Previous one is RK fourth order method. Next problem. The Newton-Raphson algorithm for the function 1 by x minus a is, see, f of x is 1 by x minus a. Now f dash x is minus 1 by x square by Newton-Raphson method. By Newton-Raphson method, xi plus 1 is xi minus f of xi by f dash xi. 1 by xi minus a by minus 1 by xi square. xi plus 1a, xi plus xi square of 1 by xi minus a, that is xi plus xi square by xi is xi minus a xi square. xi plus 1 is 2xi minus a xi square. Two xi minus a xi square. Third option is correct. Understood? xn plus 1 is xn by 2. Size of the step length is h. Harsh Kumar Jha. In that problem, size of the step is h, because our job is to calculate y of h. That's why. Next, xn plus 1 equal to xn by 2 plus 9 by 8 xn. X naught is 0.5. At the root alpha equal to xn plus 1, alpha equal to alpha by 2 plus 9 by 8 alpha. 8 alpha is LCM, 4 alpha square plus 9. 8 alpha square equal to 4 alpha square plus 9. 4 alpha square equal to 9. Alpha square equal to 9 by 4. Alpha equal to 3 by 2. Therefore, the root is 1.5. Finally, the root is 1.5. Next problem. The integral 1 to 3 1 by x dx by taking two equal subintervals each of length 1. Two equal subintervals. So here a is 1, b is 3, number of subintervals are 2, h is equal to b minus a by n, that is 3 minus 1 by 2, that is 2 by 2, that is 1. Therefore, the table x value y equal to 1 by x na? Now when x is 1, 2, 3. When x is 1, 1 by 1 is 1. 1 by 2. This is 1 by 3. Now y naught, y1, y2. We have to apply Simpson's 1/3 rule. Simpson's 1/3 rule. By Simpson's 1/3 rule, integral 1 to 3 1 by x dx is h by 3 of y0 plus y2 plus 4y1. H is 1 by 3, y0 is 1, y2 is 1 by 3. 1 plus 1 by 3 plus 4 into 1 by 2. Simplify this. 1 plus 1 by 3 is 3 plus 1, 4 by 3. 4 by 2 is 2. 3 to just 6, 6 plus 4, 10. 10 by 9. That is 1.1111 like that. Therefore, correct answer is second option. Next problem. Consider the subintervals. Consider the subintervals. The value of integral 1 by 1 plus x dx by trapezoidal rule is. Consider how many subintervals? How many subintervals? He has not mentioned. He has not mentioned how many subintervals here. To implement trapezoidal rule, you can take any number of subintervals. Okay, na? 0 to 1 means you can take step size h equal to 0.1, or step size h is equal to 0.2, or step size h is equal to whatever way you can take. N number of subintervals is not mentioned. That's why I am taking 0, 0.5 and 1. Zero, 0.5, 1. When x is 0, 1 by 1 plus 0 is 1. When x is 0.5, 1 by 1 plus half. 1 plus half is 3 by 2. 1 by 3 by 2 is 2 by 3. 1 by 1 plus 1 is 1 by 2. This is y0, y1, y2. By trapezoidal rule, integral 0 to 1, 1 by 1 plus x dx is h by 2 of y0 plus y2 plus 2y1, 1 by 2 by 2 of 1 plus 1 by 2 plus 2 into 2 by 3, 4 by 3. 1 plus 1 by 2 is 3 by 2 plus 4 by 3. 3 by 2 plus 4 by 3. Take LCM 6. 3 3 ja 9 plus 3 2 ja 2 4 ja 8. 17 by 24. 17 by 24 equal to 0.708. 0.708. Next, we have to apply bisection method. Using bisection method, find second approximation to the root of the equation x cube minus 4x minus 9 between 2 and 3. So we have to apply bisection method for the function x cube minus 4x minus 9. Between 2 and 3, a is 2, b is 3. Functional value at 2, 8 minus 8 minus 9. Functional value at 3, 3 cube 27 minus 12. Minus 12 minus 9 minus 21. 9 plus 2 minus 21. 27 minus 21 6. Clearly here negative, here positive. Root lies between 2 and 3. First approximation is 2 plus 3 by 2 because of bisection method, 2.5. Functional value at 2.5. 2.5 whole cube minus 4 into 2.5 minus 9. The result is 15.625 minus 10, that is 5.625. minus 9, that is minus 3.375. Now, to 2.53. At 2, functional value negative. 2.5 functional value negative. 3 functional value positive. Therefore, root lies between 2 and 2.5. The second approximation is 2 plus 2.5 by 2. 2.25. Functional value at 2.25. whole cube minus 4 into 2.25 that is 11.390625 minus 9 minus 9, that is 11.390625 minus 18 equal to minus 7.6093. Negative na? You have to calculate a second approximation root. Second approximation root is 2.25, clear. You need not to go for third approximation. 2.25 is the second approximation. Over. Next, the Newton-Raphson iteration formula for finding square root of n is square root of n, x equal to square root of n. Therefore, x square equal to n. X square minus n equal to 0. F of x is x square minus n. F dash x is 2x by Newton-Raphson method. xi plus 1 is xi minus f of xi by f dash xi. F of xi is xi square minus n. F dash xi is 2xi. LCM is 2xi. 2xi into xi is 2xi square minus xi square plus n. That is xi plus n is xi square plus n by 2xi, that is 1 by 2 of xi plus n by xi. Final answer is xi plus n by xi. 1 by 2 of xi plus n by xi. Next problem. By using Newton-Raphson iteration method, xn plus 1 equal to 1 by 2 of xn plus 3 by xn at the root alpha is equal to xn plus 1, alpha equal to 1 by 2 of 'alpha plus 3 by alpha, 1 by 2 of LCM alpha square plus 3, that is 2 alpha into alpha, 2 alpha square equal to alpha square plus 3. Therefore 2 alpha square minus alpha square equal to 3. Finally alpha square equal to 3. Therefore the function is x square equal to 3. X square equal to 3 is the correct answer. Next problem. The root of the equation x cube plus 3x minus 7 equal to 0 needs to be found by Newton-Raphson method with initial guess x naught equal to 1. Then what is x1? F of x is x cube plus 3x minus 7. F dash x is 3x square plus 3. Now f of 1 is 1 plus 3, 4, 4 minus 7, minus 3. F dash of 1 is 3 plus 3, 6. By Newton-Raphson method, x1 equal to x naught minus f of x naught by f dash x naught. x1 equal to 1 minus f of 1 is minus 3 by 6. 1 plus 3 by 6 is 1.5. x1 is 1.5. By using trapezoidal rule, dividing the interval into 3 equal subintervals, a is minus 1, b is 1, number of subintervals are 3, h is equal to b minus a by n, 1 minus of minus 1 by 3, that is 2 by 3. Therefore the table minus 1. Minus 1 plus 2 by 3 is minus 1 by 3, plus 2 by 3 is 1 by 3 plus 1. Modulus of minus 1 is 1, modulus of 1 by 3 is 1 by 3, 1 by 3, 1. This is y0, y1, y2, y3. We have to apply trapezoidal rule. Integral minus 1 to 1 mod x dx is h by 2 of y0 plus y3 plus 2 into y1 plus y2, that is 2 by 3 is h value by 2 of 1 plus 1 plus 2 times of 1 by 3 plus 1 by 3. 2 by 3 by 2 is 1 by 3. 2 plus 1 by 3 plus 1 by 3, 2 by 3, 2 by 3 into 2, 4 by 3. 3 to just 6, 6 plus 4, 10. 10 by 9. 1.1111. That is the answer. Understood?